Welcome to the Inventor's Edge podcast, where insight meets innovation. Whether you're sketching your first idea or refining a finished product, you're in the right place. Our mission is to equip you with the tools, expertise, and clarity you need to succeed as an inventor, while helping you conquer fears and limiting beliefs that may be holding you back. I'm your host, Scott Putnam, founder and CEO of Inventor's Edge. Before becoming a seasoned product development coach, I was a wide-eyed inventor with a head full of ideas but no clear path forward. I know firsthand what it's like to feel stuck, uncertain, and overwhelmed. Fast forward to today, I'm a successful entrepreneur with multiple licensing deals and products on the market. I'm committed to helping inventors like you overcome obstacles, conquer fears, and transform your ideas into tangible success through proven, actionable, step-by-step strategies that deliver real results. Join us as we bring in industry pros, share expert advice, and dive deep into the world of innovation. Ready to turn your ideas into reality? Let's get started. On this episode of the Inventor's Edge podcast, we have an incredible guest, Dr. Dan Brown. Dan is an award-winning designer, inventor, entrepreneur, and professor at Northwestern University's Siegel Design Institute. With over 100 patents to his name and decades of experience in business, design, and intellectual property, he brings a wealth of knowledge to today's conversation. Dan's journey is a fascinating one. He started with a background in biology and chemistry. He quickly rose through the ranks in the chemical and plastics industry before launching his own product design consultancy, Consultex Concepts, in 1991. His design philosophy, differentiation by design, focuses on identifying the white space in the market, those hidden opportunities that can set a product apart. He put his philosophy into practice when he invented the bionic wrench, a revolutionary tool that not only became a bestseller, but also taught him firsthand the challenges of protecting intellectual property in a competitive market. In today's episode, we discuss the critical mindset shifts inventors need when transitioning from idea creation to commercialization, how to spot unseen opportunities in the market, and the lessons Dan has learned in protecting his innovations from knockoffs. He also shares insight from his work at Northwestern, where he's helping shape the next generation of design leaders. If you're an inventor looking to turn your ideas into a sustainable business, this is an episode you won't want to miss. Let's dive in. Hey, welcome to the Inventor's Edge podcast. Dr. Dan Brown, professor at Northwestern University. Welcome to the show.
Hello, Scott. How are you?
Good. Thanks for being here. I really appreciate your time. And I was really excited to talk with you as an engineer with such a deep background of experience, and also as an inventor and a product developer bringing products to market yourself. I was very excited to have you on the show. And we can just jump right in here. So I was curious about, you have such a diverse background in both business and design. And at Inventor's Edge, I talk a lot about having the right mindset as well as attitude for inventing and being very open-minded about things and somewhat pliable, with different ideas and just being very open and creative. But I was curious, what are some key mindset shifts that you feel like inventors need to make, when they transition from idea creation to actually bringing it to market and commercialization?
Yeah, I think a big challenge we have in society is there's a popular mythology about the inventor and, the light bulb or the lightning hitting you. It's really much more than the flash of genius. I think the idea can be a bit of a flash at times, but ideas don't end up in the market. It's developed products. I think the reality is, as you're painfully aware, most patents never see the light of day. Very few ever get into the marketplace. So what's considered invention and new, useful, non-obvious, and what gets in the market to be a successful product that's protected by a patent are vastly, vastly different. So I think that one of the biggest challenges is that it's very much underestimated and how much effort and focus is involved in bringing a product to market and inventing.
Yeah. But what do you feel like inventors, in terms of their mindset, what needs to shift for them? Because a lot of us have ideas that just kind of bubble up all the time, and we keep a journal or we keep them on our phones and things like that. But in terms of really making that transition from becoming an idea machine to actually narrowing the focus toward, okay, this is a not just an idea, but this is actually an invention that we can bring to market, commercialize it. Are there a couple tangible things that inventors or things they could think about to do that?
I mean, I make my career around that area there, problem finding, need finding. I think the first and most important is that you're pursuing a right now real problem. Pursuing an idea that is you think is clever or you just have a fancy for probably is not going to be something that's going to be scalable and viable in the marketplace. That there is a focus, and you said focus, it's key, a way of understanding that you're at a real right now problem. There's not an existing solution out there that's working, and you have an opportunity to pursue what I call a white space to create a solution that you can patent and protect as a competitive advantage.
Yeah. Yeah, that's such an important distinction, something that you can protect, something that really is a solution to a problem that ideally, I think a lot of us like, I'm frustrated with this, so I create a product that fixes it for me, but does anybody else care? Is this a problem for other people?
Yeah, yeah, that's true. It has to be a scalable problem. Now, it doesn't have to be, something that's going to, take over the market, but it has to be have a sufficient amount of users to run a scalable business.
Yeah. Is there a number there? Like it has to at least, be useful for 10 other people, 100, 1,000, a million?
No, I don't think there's a hard number. I think it has to be a cash flow, and it has to be a sufficient revenue generator so that you can support it. And so there's a wide variety there. Most of the times, what I find is people not haven't even looked or done the research to see what other solutions are out there. They're just emotionally pursuing something, and they've not even done patent research or market research. Quite often with students, as we go through this, in my classes tend to take students through this white space exploration. They don't even do that work. And then, it's part of my role to teach them how to do the patent research, how to do the market research, how to identify what the root of the problem is versus chasing all the symptoms. We tend to view problems as symptoms, not as what the sub problems are or the roots of the problem.
Mm, that's interesting. Yeah, symptoms. I hadn't really thought of it that way. Similar to a doctor, like, okay, here are the symptoms. What's the underlying
Very much like
cause?
a doctor.
Yeah, that's so interesting. When I'm coaching students at Inventor's Edge, I like to do deep dives into things like that too, because it's like, okay, is this a frustration? Is this an inconvenience, or is this a real problem? And what is the user experience like? And then, yeah, talking about commercialization, is there a need? Is there, in the marketplace, can a company make money? Because when you pitch to a company, whether it's licensing or if you're going to bring it to market yourself, you want to know, are people going to buy this, right?
Of
Is,
course, yeah, it's a big risk.
is there a market for it? Definitely. And you were talking about white space too, and you have your concept that differentiation by design, which I thought was fascinating. It's the philosophy that really focuses on that white space in the market. Can you maybe walk us through how an inventor might sort of identify and leverage these?
Yeah. So this grew out of my work early on in my career where I had a lot of success. And when I reflected back on what was giving me that success, it was very much this focus on, in the marketplace, solving the problem, but not copying what's out there, but trying to pursue the knowledge gaps where the current solution was falling short into the white space. And the white space, it doesn't exist just in technology. It exists around behaviors, economics. There's a lot of areas. And I even focus beyond users. Now, those are important, but there's other stakeholders involved where differentiators can be employed and designed that part of that user experience, maybe it's in the supply chain or the distribution channel, that differentiation can create that competitive advantage. So bringing that focus to the where the existing solutions falling short, the knowledge gap is important. And then
Mhm.
part of this is I see it as uh, I see design as a philosophy, an approach, but it's a rivalry between existing knowledge of existing solutions and the new knowledge you can create that you can protect in the new solution. And having a protectable, creative, um, competitive advantage goes a long way to sustaining yourself in the market.
Yeah. Yeah, that's such a great point. You know, companies are looking for that too. They don't wanna have just a me too product that they roll out and, try to get everybody excited about.
Or have a product they can't protect.
Mhm.
So that's extremely important. It's a invention and inventors' rights. It's a whole another podcast or two, but
Yeah.
it's up to the inventor, the designer, to strategically design their solution so they know where that existing boundaries of intellectual property are, what they can use of prior art, and what to avoid. So you don't want to go out in the market and have someone sue you. And then that allows, for me, in my experience, is that gives me insights and prompts me to go in particular directions. And I found myself, and I've 45 U.S. patents now and a lot of products that oftentimes in my journey, it was this pursuit of that new knowledge and the research around it that pushed me into the direction that got me to the new knowledge.
That's interesting. So using the patent searching process as kind of a framework for the innovation itself.
Around the technology for sure, yes.
Yeah.
But
Yeah.
there's also a whole area of human-centered design, which we're very focused on here at Northwestern. I call stakeholder-centered design that also deals with the behavioral aspects of relationships with products and services and the economic aspects, which are also important.
Right. Yeah. And within the framework of the economic considerations, I mean, do you get into with your students at Northwestern, like size of the product, the package it's going to be in, how is it displayed, how is it merchandised, and
I would say that would be research into the distribution channel and understanding if you build a product, everything now is what's called cross-docked. And if you don't package that product for cross-docking, which means the truck picks up the truckload at your plant. They go to a distribution center, and it goes from that truck into many other trucks that are on a schedule. They don't go up in the inventory anymore. If you don't have the setup for the labeling, the packaging, the size pallets, automatic handling, you won't be able to sell that product. The specifications for packaging, for shipping and stocking, whether it's Amazon or QVC or Walmart, are extensive, and you have to design your product hopefully so one embodiment of the package can work for all of them. It could be a puzzle.
yeah, how much engineering goes into that aspect of it in
I've
general?
definitely gotten differentiators out of packaging, and particularly in the area where for recycling and using packaging so that it can be recycled. And
Yeah,
so that's been a big area in the last 20 years. So that's important. And it has to do, if you're packaging something that is perishable, obviously oxygen barriers and those type of things. If you're packaging something that you want the paper to go one direction in the recycling stream and the plastic the other, that's a whole nother process. And a lot of the old technology used to laminate like paper and plastic together. Well, that renders it, you can't recycle that because the paper and the plastic go to two separate streams. So there's a lot of design and engineering that goes into that. And quite often people don't even think about it until they've done all the product work and testing and even built tooling when they sometimes design themselves into the corner because that limits their ability to handle those other downstream requirements that are necessary for mass distribution.
yeah. I think the average inventor, we get focused on our product, that's our solution, and not thinking about maybe a little bit about the user experience, but not necessarily the the
The
the rest of the
stakeholders,
story, right?
yeah, the other stakeholders. I call it stakeholder design because people in the supply chain, the people that assemble the product, your internal stakeholders for deploying cash flow and managing or assembling product. They're all important to the process. And sometimes in markets, you can differentiate the product, not sometimes, many times, also in the supply chain and in the distribution channel that creates that competitive advantage. And those are powerful when you can get those multiple advantages put together.
Yeah. It really, you think about it all the way back from the beginning of like, I have this idea, I have this concept. Maybe it's something that is on a longer pole, like some kind of a cleaning device. Like, okay, we need to be able to break that long 3.5 foot pole, thinking about shipping, thinking about how many can we get into a master carton, condensing it down.
Even the assembly, how you can assemble it in a cost effective way. I have a product here that this is a product that I brought out called the bionic wrench. And it's got a very unique mechanism,
Yeah.
American made. If I didn't have the ability to optimize this in the design for assembly and manufacturing, and then move through the supply chain in a way that was efficient, I never could have brought it out in the market. Most of the products in that category are all imported, low cost, and it's impossible to compete. But I was able to strategically, after I developed the form and the function, go into the design for assembly and manufacturing and employ stamping techniques and assembly techniques and robotic riveters so that I can gain that productivity necessary to be competitive.
How much of that, I'm sure our listeners some of them could be maybe they don't have a background in manufacturing, they don't even know what all of those things are. How valuable is it to learn about how products are made in general? And are there a couple maybe good resources you could offer for people just to learn about, let's say they have a product like yours that's maybe a new type of wrench or something. How do people begin to learn about how those things are even made?
Well, you can go to engineering school, but not everybody has that opportunity. But I think
Yeah.
the best way to start is with benchmarking similar products and then doing a deep research into how they're made. And now with YouTube and all the social media, you can find it. And when you get those potentials, then you need to put on your networking hat and go out and start working with supply chain. Now, it used to be easier. We had a very deep supply chain when I started this some 40 years ago in the States, but a lot of that is left. And so you don't have the access, but there's still some out there. There are other consultants, et cetera. So, the main industries of, say, metalworking and plastics molding, those type of things are, there's typically someone in your area that's doing that you can draw upon. Question is, are they gonna, do they have the time to walk you through, the stuff? And you just have to find those right circumstances and keep looking. Looking for mentors, that's a great way to do that. If your technology is pushing the technological edge, you typically are arriving, you're somehow in that area and you have your roots in that area. That's it, you know about it. And then there's nothing wrong with going out and buying subcomponents from people that have that expertise. But the problem with that is the more you sort of say at a higher cost, it's not a lean design, it raises the expense and that becomes a problem. So you have a lot of economic, behavioral, and obviously performative aspects of a design that need to be considered. And just like that packaging story, they have to be considered up front because those trade-off decisions, that's how you make them, right? Do I go with this manufacturing process versus this one? You have to look at beyond maybe just performance and looks, but what are the economics of it? And what is the capital investment? What's the cash flow? Those type of things are very important in the big picture.
Yeah, great points there. I know we live fairly close to a couple of different tech schools. Even community colleges sometimes have some manufacturing processes that they do. What does Northwestern have in terms of like on campus manufacturing facilities or capabilities?
Well, we're going through a change, I guess. One of the reasons I'm here, I've been teaching here 14 years now, but for a long period of time, we stopped trade schools, we stopped all that, and everything was very theoretical. So you had shops, but it wasn't a deep dive. Western, back in the mid 90s, we had a gene that really embraced design in the process, and the school had subsequently invested in really good machine shops and machining and different manufacturing process opportunities, and created a program called MADE, Manufacturing and Design Engineering. And me and my colleague Dave Gatchell were principal faculty in that. And so we have actually, you could basically say, mechanical engineers who specialize in this, and we take them through the process. What's different is, well, I have my PhD now. I got my master's when I was 50, and my PhD, I started at 55, and I got it when I was 60. 69, I'll be 69 this summer. I also had, at that time when I started, 35 years of manufacturing experience, which I could draw upon practically so that I can facilitate projects and mentor students through that process. You find that, I think, in some universities, but you don't find that in all. And I think there's going to be a much stronger push for that because, as Einstein said, in theory and practice are the same, but in practice they're not. And it very
Yeah.
much applies here. My ability to understand the technology and the theory, and then draw upon all the years of experience in different technologies, they come together in this creative process that allowing me to optimize and teach students how to do that. I guess
Yeah.
one thing also I'd say is I like to rely on a thing I call MacGyvering. And
Hmm.
MacGyvering is when you can take a team and rather than have them go down to the shop and build everything from scratch, you can get a benchmark or something else and then look at that particular area you're trying to mock up or prototype and make it out of something that's already there so you can do a quick and dirty test to see if you're going in that right direction and staying
Hmm.
on track and doing that versus being distracted by a lot of things. And engineers tend to, they're distractible. They want to, you can go out and buy a circuit board or you can build a circuit board. And some students, will get sidetracked in building the circuit boards, but that's not solving the overall problem. That's not the design problem. That's important for electrical engineering and maybe a capstone for electrical engineers, but that's probably not a good design capstone because you're not solving that problem. You're in a tangential area.
Yeah, such a great point. And I don't know if I would say the inventor brain is that way too. It's like squirrel. It's like, they just veer off. And I've been guilty of it myself, going
Mhm.
down these rabbit holes thinking it's so important and I need to go, down this side trail 10 miles so I can figure out something and then I'll come back. And it sounds like usually there's a way around that.
So that's interesting too. And yes, what's different at Northwestern is that we have a focus on design as in design engineering. I'm in the Ford design engineering design building, and that combination of design and engineering, where they're very complementary, they're also different processes. I like to tell the students that when you're doing engineering, quite often you're building the bridge in the same process, the same way. You're using the requirements for maybe a different length or wind load weight load or whatever, but you're using an established process. The pattern's in place, it's logarithmic. But what happens when that falls short?
Hmm.
You have to design a new way. Well, I have a lecture I give. Design projects are different, and it's about building that bridge in the same way versus building it in a new way. That exploratory process and going into the unknown is not as algorithmic, but yet there is a set of heuristics, a pattern around design that is what I studied for my thesis and my PhD that is consistent. Like we talked earlier, problem finding and framing, getting to the root of the problem, stakeholder finding and framing, need finding, particularly unmet needs, finding those unmet needs that can add value and give you focus toward that white space or that competitive advantage. And then the process of quick and dirty mock-ups and testing these sub-problems. Many people will tackle the whole problem and they're tackling not the root of the problem, but the symptoms. But when you look at these big problems, you can decompose them into sub-problems. And then you can rank them. What's the hardest one? Because if you take the easiest one, you can spend a lot of time, won't you never solve the hardest one. You want to go after the artisan first. And
Okay.
doing that allows you a systematic way of going through that design process. Then you bring together with your engineering process to get it to commercialization. So this whole area of design, design thinking or whatever, is a creative problem solver is becoming much more formalized. And I say something that can be controversial, but while we all understand the scientific method, we believe in the scientific method, you can do experimental methodology, you can handle all the variables, you change one and test it and know if it's right or wrong. That's it's a very strong way of exploring the world. And it's very deductive in its logic. But when
Mm.
you're designing, you don't have that certainty that you can say you're working with humans. You can't control all the variables, and the variables change by the humans. It's not the product of nature like gravity or temperature that you can measure. That that often subjective and qualitative information is extremely important. And there's a process to manage that in the design process, and that's a design methodology. And what I like to teach, and we teach in our main program, is that this design methodology is just as rigorous, just as important, and it's got a methodology, a foundation that's on par with the scientific method, but it's a different approach.
Hmm.
It's a design approach versus, say, a practical engineering approach. And when you're going into a new space, if you don't take that approach, you're usually not going to go further away from your existing knowledge. You're not going to get to that new knowledge.
Right. Yeah, such an important distinction there. And I love the MacGyver approach. Like sometimes you just need to get in the garage and tinker around and play with things and see what works. And then you can, through iterations and continuing the idea of form and function both, the aesthetics, more of the industrial design part of it as
And
well
you
as,
have to have empathy. You have to get out of your own head. Your bias can take you down a road that it maybe works for you, but it won't work for the stakeholders that you're looking to work with. And so
yeah.
understanding those, again, qualitative, subjective areas of design is extremely important.
Yeah. It's hard being objective about your own product.
Yep, yep.
You birthed you birthed this from your brain, right? It's yeah, it's difficult. I've run into this all the time with coaching where it's like nobody wants to hear anything negative about their product. Any feedback is, it's a little apprehensive about that, but it's such an important thing when you start getting it out
So
there.
what's interesting, and probably most inventors haven't heard this is not something new in humanity. It's called the endowment effect. It's based off a area of economics called prospect theory, and it's been very well studied in other areas, like when people buy and sell stocks or whatever. This whole endowment effect and areas, another thing called loss aversion, they all play out in this design process. Loss aversion would be I'm going in to design a product that, to compete with Apple, but everybody's so endowed on their Apple products, I could have a much better product. But how do you break free that emotional relationship that the stakeholders have with their Apple products? And those are real challenges, but they're not maybe performative challenges or even economic. They're behavioral, emotional. And
Mhm.
and you need to be able to test that and tease that out so that you can develop something that has the ability to scale.
Yeah. Yeah. Great stuff. I want to circle back to your bionic wrench, which was this massive success. You had to fight off a lot of knockoffs with that. I know we talked before and it was like my
Still
mind
fighting
was
off that.
blown with what did you spend over $1 million on attorney's fees? And I guess
Well, we
the,
had that's the unfortunate the challenge small inventors have. Well, one, the intellectual property system is one system for everybody, from Apple and Elon Musk all the way down to someone in the garage. Yet the access to it and the access to fairness is very, very, very challenging. And what's happened in the unfortunate last 20 years is we've had a lot of lobbying of Congress and the legal system where big companies are while when they were in the garage, they believed in inventor rights or whatever. When they became big companies, they want to monopolize. And so
mm,
the whole, again, this is another podcast, but it's really changed, which makes it all the more important for inventors to understand intellectual property and what they can do to protect themselves in the most robust way. But when you have a successful product, you do attract people that want to copy it.
Mm.
We did, after we were in market for about 7 or 8 years, our largest customer, who was Sears, wanted us to bring the product to China, really putting pressure on us. And I had proven it was very successful and we could make it in the States. It was a very big, it was a part of our strategy. And to do that, we were sacrificing margin and different things, but we also had a low overhead operation and we had a good supply chain that was working hard to keep it in the States. But they wouldn't take no for an answer. So they got
Mm.
together with their largest supplier, who had moved most everything from their tool product lines to China at that time. And they went out and knocked us off. You could look it up on the internet. Loggerhead Tools, Sears. It's been a lot of things written about it. I was on ABC News with David Muir a few times. It
Mhm.
was a classic. Uh, you're a victim of your own success. After 7 years of litigation, $3.5 million cost, which I was able to get a contingency fee attorney and some investors and our own money. It was a team effort. We won willful infringement against both parties. And that was a good feeling because, they were saying, oh, you've invented this and that. It was all BS. But because of the lack of accountability in our legal system, big companies, it's called efficient infringement or predatory infringement, they will knock you off. And there's not much you can do except fight. And it used to be you could get an injunction and stop them. So they had some power. But because of this lobbying that they talked about and some court decisions, you can't get an injunction anymore. So they're going to license from you or they're going to respect your patents. If they want it bad enough, they'll try and steal it. And the lawyers get rich. And it virtually destroyed us because during those 7 years, our market price went from $20 a unit down to like $10 a unit. And
Mm.
when you have these knockoffs, they're not the same quality, and then your reputation can suffer. There's a lot of damages. Well, we won, and we won willful infringement, was really good. But then the judge took the award away, and we don't know why. We can't explain it. And we then appealed and went to the Fed Circuit, which is where you're supposed to go. They took our case, but then they did a thing called Rule 36, which means they're not going to comment. I don't think I'm going to surprise anybody here with saying that our legal system is subject to a lot of outside pressures and things that you think should be logical and fair and don't always play out that way. And in the intellectual property area, unfortunately, that's been my experience. But
Man.
stop them. But in stopping them, it almost took us to death. And now I just had a legal team want to pursue other infringers with the way now that the products can come in from offshore in the mail and the de minimis. If something comes in under $800, which the administration is trying to change now, it comes in. They pay no taxes, no duties, nothing. No, if I sell on Amazon, I have to pay the taxes. The online
Mhm.
sales were first tax free, but states are collecting taxes now, but it doesn't happen for the imported products.
Wow.
Or so I've got knockoffs that are coming in the mail from China, and we subsidize it right away. Our post office subsidizes all the packages that come in, and I can't stop them. It's just impossible.
Yeah. So with that in mind, I mean, I know inventors don't want to hear that and they want to stay excited about their ideas and
You have to be realistic. You really have to be realistic.
yeah.
You should work on getting trademarks and trade dress, copyrights and patents, not just utility patents, but there's a whole, again, that'd be another podcast, but there's a whole strategy around building that barrier around your product.
Yeah. Building like a wall of protection and just
And I hope the current administration, I mean, politics aside, I'm not a political animal, but we have to deal with this. This is really destroying our ability to have American jobs, and the fact that someone can't do what I did, make that investment. When Sears did that to us, we had to let 40 people go.
Wow.
It was devastating, and it was hell. It's just I don't know how else to say it other than when you lobby and talk. Join U.S. Inventors. It's
Hmm.
usinventors.org. There's on the front page of it, you probably have 20 examples of like what I just said with evidence. And that organization is the best organization out there for small inventors in trying to protect their rights. And it's the people that are there are I just have complete respect for. They work very hard. Inventors don't have a lot of money. We're not going around in Washington and throwing money around, which is how you get
Hmm.
things done. We just need to have this grassroots appeal to our elected representatives to stand up and fight for us. And that's the organization that really does it the best in my book.
That's great. I know we talked in some detail about that before. Yeah, it's a great organization. That's usinventors.org. Is that
Yeah,
right?
that would be the website.
Perfect. Yeah, that's awesome. And then a lot of resources there. And I think it's good to get involved with communities, inventing communities. I feel like we have power in numbers when we get together.
You find resources. I mean, they're not going to be the inventor resource as much as they'll help you with your intellectual property, and you can find a lot of it. Like you yourself, you do a lot of the basics for design and invention and helping inventors, but you also need that network for your establishing your rights and protecting your rights.
Yeah. Yeah. And I know it's as it seems like the landscape's shifting under our feet. It's good to stay at the forefront of all of that, all of the changes that are happening right now.
If you don't, I mean, let's face it, you're risking when I started the Loggerhead, I had had a lot of experience and a lot of success in the marketplace. First for companies that I had worked for, so they funded the bill, and then later for people that I did my consulting work for, they funded it. And it was a lot, things where you had to build chemical plants and stuff like that. But I did this at the Bionic Wrench as a case study, and I wanted to fund it myself. But even so, just the tooling for our product line is over $1.5 million. I've spent over $1 million in intellectual property, not including the lawsuit, and it's a lot of money. So I basically, I funded the development, and I took a paid off house and remortgaged it, and I basically took my retirement funding at the time, and I rolled that dice. If you're going to take that kind of risk, you need to you need to have your A game on all fronts. You just can't go blindly hoping that something's going to happen. You're going to lose your investment.
Yeah. And we talk a lot about, licensing a product versus venturing. And I think for those reasons, a lot of people like the licensing model.
I'll bring that up. A lot of times someone will say, well, we'll take a license, and they work a deal out and they ask you to assign the patent. But then, they get it. And whether they have success or not, if they don't have success, they don't have cash flow, you don't get anything coming in, and you don't own your patent anymore. And you want to get it back, you have to get lawyers to get it back. There's very important to talk to someone who's experienced in licensing to make sure that you create a license that if the performance in the license isn't there for whatever reason, you don't have to hire a law firm to get it back. I personally would not assign a patent anymore. I will give a royalty free license or give a license with a minimum royalty or something that makes sense, but I'm not going to lose that patent because if
Hmm.
my partner doesn't make it or can't make their obligation, I want to own that patent so I have the option of using it moving forward. And I
Yeah.
think a lot of small vendors don't understand the legality and what's going on in those licensing arrangements. On the other
Right.
hand, people are taking licenses, they want the rights. Then it becomes a negotiation. What are you willing to pay for those rights, et cetera? What are the minimum royalties? difficulties. You need to have somebody look at the dynamics, because every case is different, and try to see what's fair for both parties.
Yeah. Yeah. And I think in my experience, the inventors are so excited about just getting a licensing deal. They're not maybe less concerned with like, what is it actually saying? What are your rights? Do you have performance clauses? Do you have things that will protect you in that deal?
Who pays for what? When you get someone knocks you off and you've licensed it, if you have not written the license appropriately, they're going to expect you to do that. Well, you're going to come up with that kind of money to file a lawsuit. It's one going through district court with one defendant is over $1 million, and then you can, get an appeal. You can go to the thing called the PTAB. It's just a lot of pitfalls. That's what I was saying earlier. Used to be, you had a patent, it was presumed valid. The courts would give you an injunction. In my case, if Sears if I knew that I could get an injunction on them, they would not have developed a competitive product that knocked me off, because they wouldn't want to make that investment. But knowing that they can sell that for years, and then, if I can get them to court and survive, they may have some accountability. Now, they did that, but it doesn't happen. It's very rare, and a small inventor is going to have the wherewithal to do that.
Yeah. Yeah. It's such an important topic, and we talk a lot about that and talk a lot about keeping things simple and starting with a simple product and just really learning the process and doing it the right way, going into it with eyes wide open so people know what to expect. And I know a lot of inventors struggle with balancing that innovation, with the business strategy. How in your opinion, how can they ensure they're not just designing a great product, but also building really a sustainable business around that for those that want to venture and they want to go all in?
Well, one of the things, just like design or invention, I mean, it's the bandwagon or the popular mythology. What is innovation? What is design? So I've studied this academically. My PhD is in this. From my perspective, design is how humans seek, conceive, and create new knowledge. It's that new knowledge rise we talked about. Innovation is how that new knowledge competes with the existing knowledge. And the metric of innovation is competitive advantage.
Mhm.
So that's a long answer. My short answer is you have to stay focused on creating competitive advantage. If you can do that, then the level of innovation, how much competitive advantage you've been able to create and then protect.
Yeah, that's great. Competitive advantage. I hear like points of difference, what makes yours different, but not just different, what makes yours better? What is your competitive advantage? That's great advice.
A lot of people approach it by, let's do the business model first. And in my role, I sit and do a lot of competitions for teams working on things, a lot of entrepreneurial ones. And quite often the team's got an idea, then they go out and they do a market analysis and they put together a business plan, but they have not created any competitive advantage. And then, they're at the during the question and answer, I'll say, "What's your competitive advantage?" And they'll look at me and they'll say, "Well, give us $5 or $6 million. We'll hire some smart people, and then they'll do that, and then we'll have it." Well, that's the cart before the horse. You have to have the competitive advantage first, then you should do that other work. And you can do it; they're not mutually exclusive. You can start thinking about that as you're working on it. It's important to have that understanding that no value is created unless you can create that.
Which starts really at the very beginning with researching core problem, not just the symptoms, but what's the problem behind those.
And how you can solve it creatively and protect it.
Hmm. Yeah, exactly. It's interesting too with your work at Northwestern, you work with a lot of future designers and leaders. What are some mistakes that you see a lot of those new inventors make? And this is kind of a broad-based question, but what what are some mistakes and how can they avoid them?
Oh, if they're human, they follow the mythology and they believe that. The mistakes is I like the breadcrumb teams, putting them in the position to learn from mistakes, but not go off the deep end. And so we go through a number of courses that teach them about different levels of design all the way through our a capstone. It's a 1 year capstone. Teams all do white space projects. They first go out and find real right now problems, and they add provisional patents and at the end of the school year and business plans, and they all file provisionals. They go through the whole process, but you can't learn that overnight, and it's very hard to learn on your own. There's plenty of videos out there. There's a lot of good books talking to people like you and myself. You just have to immerse yourself. You can't, sort of drink your own Kool-Aid and think, well, because I did it, it's going to automatically happen. It doesn't happen like that.
What would you say is if you had to pick one mistake, what's the biggest mistake that inventors make in general?
Not doing the problem research up front and identifying the real root of the problem or getting close to the sub problems that you have to solve. Chasing symptoms.
Yeah. Yeah. That's good. That's a good theme. I wish the medical community worked from that model as well. Let's
Well,
just
some
not.
problems, let's face it, I mean, curing cancer is a very complex problem. But a lot of the, problems arise out of the needs, and then getting to the solution becomes, I don't want to say self-evident, but there's a pathway to it once you start decomposing it into sub-problems and working on them individually. So it's a whole evolutionary thought process of mocking up and testing and going through that allows you to get there in a, I don't want to say systematic way, but a heuristic way. Heuristics are rules of thumb, where maybe building the bridge in the same way, once you've done it over and over, it becomes systematic. But when you're exploring and you're going up the mountain and there's many paths, it's a heuristic. Maybe you're going to follow the sun or follow, a river, or you're following the heuristics of that process.
Such great advice. I feel like I could talk to you for the next 17 hours and do all these deep dives. With that, has been an awesome experience having you on. It's been great chatting. Other than the U.S. Inventor, are there ways people can get in touch with you? Are you open to questions? I
Yeah,
didn't know.
I mean, I'm a busy guy and I've got a lot on my plate. But one of the things I would say is I wrote an article for, I'm a fellow at the National Academy of Inventors, and I have a paper here that I wrote particularly because there's not a lot of academic writing or research around design. We're still a young discipline as an independent discipline. But in this paper, my son and I created a product during COVID when people needed PPE. And I don't want to go into it all the way, but I'll send you the link and you can put it out there. The first part of the paper talks about the process, and the second part is a case study of what we did. And to make a long story short, in looking at the problem decomposition, the problem wasn't a face shield because they're omnipotent, was getting face shields in the millions very fast. It was
Mm-hmm.
more of a manufacturing problem, and I recognized that. And as I went through the problem decomposition, I realized that, well, why do I have to make all this headgear and things on face shields when I just need a cough and sneeze shield? And it hit me as I went through that. If I can get rid of those components, I can have a pathway to something. So I basically created a face shield that snaps flat, which is easy to make, but you can origami it up and put it on the bill of a baseball cap. And
Mm-hmm.
we got that out in 6 weeks. We sold 1 million of them and we donated 1 million of them.
Wow.
And it's just a classic example, a basic one that allow people to see that process. To answer your question, read this paper. And if you have questions on that, I'm happy to answer that. But, you know, if you're really interested in it, I think that you have to do that kind of research.
Yeah, yeah, I'd be willing to do a little bit of a deep dive into things. And I like case studies because they're very tangible. It's not a lot of theory. It's like, here's was a problem, here's our approach, this is what we did, here's the result.
It's the best way I think to teach design.
Yeah, yeah, that's fantastic. And you're on LinkedIn as well. I mean, if people are listening, they want to connect on LinkedIn. Is that okay? Sounds great. Dr. Dan Brown, I really appreciate your time. Thanks so much for being on.
I'll send you the link for this case study. They can go right to the National Academy of Inventors and download it and read it. And, you know, I'm happy to take the time. I wish everybody the best of luck, but don't underestimate how much work it is.
Yeah, get ready to roll up your sleeves. It's time to go to work if you want to do it the right way.
Yes.
Awesome. Well, really appreciate your time. It's been an honor having you on, and I'm excited to get you back on for another episode.
Sure, we can talk about more specific things, intellectual property, licensing, whatever you want.
That sounds great. And maybe if people are listening, if you want to comment and let us know, in the comments what you'd like to hear more about, and maybe we can get Dan back on. That'd be great.
Sure. Happy to do it.
Awesome. Appreciate it. Thanks so much, Dan.
Good luck.
Take care.
Bye.
Thanks for tuning in to the Inventor's Edge podcast. I'm your host, Scott Putnam, and if you enjoyed today's episode, don't forget to like and subscribe, leave a review, and please share it with fellow inventors. Your next breakthrough could be just around the corner. For more tools, tips, and resources, visit us at inventors-edge.com. Until next time, invent with purpose, innovate with passion, and bring your ideas to life.